You know this constellation Orion? It's got this red star right here. It's called Betelgeuse, and I've got beef with it. I flick this star off every time I see it in the night sky. It's a confusing jerk, okay? It's been dropping its brightness in and out over the last few years, making everybody think it's gonna go supernova, but it's just teasing us.
And that's kind of annoying, so this star, yeah.
Yep, this is so annoying, I do a whole show around it.
The other thing about this star is that it's very, very far away.
The star is so far away, it takes 400 years for light to reach it. So my insults are never gonna make it in time. In fact, Betelgeuse is just getting Shakespeare now.
The other thing about Betelgeuse is that I once was doing a show here, and it came and was really rude. The guest is Betelgeuse?
Okay, I'm becoming supernova. Get out of here! And don't come back! I hate you, Betelgeuse! I hate you!
So yeah, I'm an astronomer who has an active feud with the star Betelgeuse. Not that one. But something was missing. I'm a scientist and I wanted to have a scientific reason for this beef. Luckily, astronomy has a wonderful tradition of April Fool's Day papers.
Every year, there's an opportunity for astronomers to waste their time writing an April Fool's Day paper. And I've proudly done that for 3 years in a row now.
Folks spend their time writing real, fake science papers and post them on the official archive. This April Fool's Day was my opportunity to do some science and win this feud. But the deadline for the April Fool's Day papers was coming up fast. I needed to lock in and do some science.
And so the writing began.
First off, I bailed on all my commitments. I was gonna go to a Frisbee tournament that weekend and I got out of there. Then I got to writing. The figures are the most important part of a paper, and I already knew what I was gonna have for figure 1.
The first figure for the paper. It was me flicking off Betelgeuse.
Then I needed to get the data on the stars. The important information about a star is its color, its brightness, and how far away it is.
And I needed this information, so I went to 2 different places to do that. One, I went to the Hipparcos catalog, and this helped me make a catalog of the 5,000 brightest stars. Then, I went to the Gaia catalog, which is an amazing spacecraft that has revolutionized astronomy. I'm really serious about it. It has changed my entire life as an astronomer. There's astronomy before Gaia and there's astronomy after Gaia. And what Gaia did was give me all that data for the 5,000 closest stars.
Finally, I needed one more thing, a poem. I reached out to my friend Will, and I called him and I said, "Hey Will, I need a poem." And he said, "What?" And then he said, "Okay." And so, I had everything I needed. Because the reason for the beef? It all had to do with stars. You see, we as humans have only really understood stars for like the last 100 years. In fact, it was the PhD thesis of Cecilia Payne-Gaposchkin 100 years ago in 1925 that revolutionized our understanding of what a star is. So this is, go Cecilia, yeah, Cecilia fans! What she helped unlock was the understanding of the relationship between the color of a star and how big it is. And the physics behind it is easy to understand. Here's what you need to know. There's a big fancy word called hydrostatic equilibrium, but basically we're playing tug of war inside of a star. The gravity from the mass of a star is crushing and pushes down on its core. The core tries to push back by releasing light. The light we get from the sun every day is because of it wrestling with its own gravity. Stars shine just to survive. Not only that, but larger stars have to burn hotter to remain balanced. So just to make that very clear, a bigger star has more gravity and has to burn hotter, has to release more light, and the smaller star has less gravity and therefore can burn cooler. How hot something is related to its color. Think about flames on a gas stove, or the temperature scale of light bulbs. This understanding of the color and the physics can be applied to any size star, all the way from the smallest, reddest, cool stars up to the biggest, hottest blue stars. And what I'm not showing you in these animations is the relative size of the stars. This is a little more accurate.
This would be a lovely sequence. I would love to be able to teach people this and say, go out into the night sky and look for a red star, look for a blue star, look for a yellow star. You'll see the sequence. But it doesn't work because there are no M stars in the night sky.
And that's why I got beef. And you might be saying, Mark, you showed us a red star at the beginning. What do you mean it doesn't work? Well, that red star is not a balanced star like I was talking about before. The color and size relation that I just told you about is only true for stars that are balanced. For stars that aren't balanced, the rules go out the window. And in fact, the red stars you see in the night sky like Betelgeuse aren't the red small ones from before.
It's one of these blues that have evolved into something this big. This is the relative size of a red supergiant star.
They're out of balance, have grown to huge sizes, and cooled down to this red color. So all the red stars you see in the night sky aren't the small ones that I was describing, but the big blue ones on their way out.
So we've done it. Beef is acquired.
My reason for picking on Betelgeuse is because it prevents me from explaining this simple rule. So I had my beef, but then I realized, where are the little red guys? Why can't we see them? These small stars are so hard to see just because they're not bright at all. They are giving off some light, but it's just the astronomical distances are too great to be able to see them. But they are there. In fact, they're the majority of our neighbors. If we look at the closest stars to us, the vast majority of them are these small, redder stars.
And just to make this point a little more clearly, here we are at the Earth, and we're going to zoom out a bit, and the stars you're seeing now are kind of the bright ones, the ones you can see with your eyes. But if your eyes were good enough, you could see all of these stars in a given night, right? These are just the ones closest to us.
If we look at the area around our sun by only the brightest stars, it looks like a pretty empty space. But this is what Gaia unlocked for us, a map of our neighborhood. And all of a sudden, you see these faint red stars take up so much space. These are the stars that we could interact with a radio signal. It's not like Betelgeuse that's so far away, it's just getting Shakespeare now. This is our neighborhood, and these are our neighbors.
So I realized that I only needed one other figure for this paper. And so I made it, and it was this.
This is a research level figure, but you already understand it, and I'll show you how. From top to bottom, we have the brightest stars, the most luminous, that give off the most light, and the faintest stars at the bottom. And then from side to side, we have the reddest stars on the right, and the bluest stars on the left. And going from the bottom right of this figure to the top left are the smallest, reddest stars up to the biggest, bluest stars. And this is that trend that you've already understood. And you also see in the top right, Betelgeuse and the other big red stars interloping and ruining that trend. But what I also want to point out about this figure is how it was made, because it requires both the 5,000 brightest stars, which represent the edge of human ability to see. So these are all we could see with the naked eye. And then also the 5,000 closest stars to cover the faint regions. And this represents thousands of years of astronomy, through Cecilia, through Gaia, to be able to understand this part of the plot. And so together they combine to show us 10,000 snapshots of stellar lifetimes, covering the full range of stellar existence. At 2 a.m. the morning before the paper was due, I submitted it. And the next day, it was rejected. Maybe it's because I stayed up until 2 a.m. writing it. Some of it wasn't very good. I also think it might have been figure 1. But what lingered in my mind was suddenly an appreciation for Betelgeuse.
This journey really affected me in some way. Like, I cried twice while writing this. Because I felt this connection between the understanding of astronomy from like 100 years ago, through Cecilia's revolution, through Gaia's revolution, through our nearest neighbors, and I realized, what am I doing? Why am I wasting my energy being mad at some distant orange hole that will never hear me? When what I could be doing is looking at those around me, building connections with them, and finding ways to strengthen those things, right? That's where I should be putting my energy.
And so it felt like it was time to apologize to Betelgeuse. So I reached out to my friend Will, and he wrote me a poem in a style, hopefully, that Betelgeuse would appreciate.
To beef or not to beef became my question. For how to hate the cosmos' favored sun, a chart to fire, read aberrant suggestion of knowledge hidden, lessons to be won. To Betelgeuse, Orion's pauldron star, our beef is squashed. I ne'er resent your fame, your gas, your class, your light, yet from afar claimed learned and spat spite, now ashamed. Your years are few, but mine number fewer. Let's spend not time remains on petty curse, for entropy in time seals both our fates. And you, not I, the light of the universe. Dear Betelgeuse, my beef was not with thee. Your hidden red light knowledge set me free.